Hello students, we will class torsion definition. So let us just recall what is meant by torsion. So start with a unit speed curve gamma in R3 in the space. Let t be the unit tangent vector. That means t equal to gamma dot, and let kappa be the curvature. So curvature, this is defined as norm of gamma double dot, which is equal to norm of t dot, and assume that the curvature is non-zero. Okay, now you define the vector n is equal to 1 by kappa times t dot. This is called principal normal vector. So n and t dot, they are in the same direction. Now you look at b is equal to t cross n. Let us differentiate b. So b dot is equal to t dot cross n plus t cross n dot. But t and n dot, they are in the t dot and n, they are in the same direction. T dot and n, they are in the same direction, so their cross product is equal to 0. So this part will be the 0 vector. So you are left with t cross n dot. So this says that b dot is perpendicular to t. Now b is a unit vector. Why? Because both t and n are unit vectors. Why n is a unit vector? Because n is equal to 1 by kappa t dot. So kappa is norm of t dot. So this is t dot divided by norm of t dot. So which is equal to so norm of n is equal to 1. So n is a normal vector, n is a unit vector, t is a unit vector. So t cross n, that is also a unit vector, because the angle between n and t is pi by 2. Why is that? Because n is defined as 1 by kappa t dot. T is unit tangent vector. So t dot, that is a vector perpendicular to t. That means n is a vector perpendicular to t. So n and t, the angle between them is pi by 2. So norm of b equal to norm of t into norm of n into modulus of sin pi by 2, which is equal to 1. So b is a unit vector. Since b is a unit vector, b dot is perpendicular to b. So b dot is a vector perpendicular to both b and t. But you are in R3, so there is only one direction which is left, which is the direction of n. So b dot must be a vector parallel to n. Therefore, b dot is a scalar multiple of n, and we will put a minus sign here for computational easiness. And this scalar tau is called the torsion, and the torsion can be evaluated by taking inner product in this equation with respect to n both sides. So tau equal to minus b dot inner product with n, and this tau is the torsion. Now we will prove a proposition how to compute the torsion without making the given regular curve a unit speed curve. Sometimes making a regular curve a unit speed curve is a tougher job. You can do that, but maybe a tougher job, because you have to find out the arc length first, and if you parameterize with respect to arc length, you will get a unit speed curve. But arc length, that is given by the formula s of t equal to integral t naught to t norm of gamma dot of tau d tau, or norm of gamma dot of u du. So this involves a process of integration which we may not be able to do always. So we need a formula for torsion directly in terms of gamma without making into a unit speed curve. So assume gamma is a regular curve and I am assuming the curvature is non-zero. Non-vanishing curvature. That means at every point on the curvature is non-zero. For such curves only, torsion is defined with non-vanishing curvature. Okay. Then torsion tau is given by the formula gamma dot cross gamma double dot inner product with gamma triple dot divided by norm of gamma dot cross gamma double dot square. Proof. So I will divide the proof into two parts. Case 1, gamma is unit speed. In that case, tau is given by the formula. Tau is the torsion minus vector n dot b dot product is commutative, so minus b dot dot n is the same as minus n dot b dot, and this dot you read as inner product, minus n inner product with b dot. So that is equal to minus n dot, inner product with, what is b? B is t cross n its derivative with respect to that unit speed parameter. It may be arc length or anything else. So it is minus n inner product with t dot cross n plus t cross n dot that is equal to but n dot and t, they are in the same direction. N and t dot, this the first term. N is a scalar multiple of t dot. So this is the zero vector. So this is minus vector n inner product with t cross n dot now let us substitute for n, but vector n equal to 1 by kappa t dot but t dot is gamma double dot, so 1 by kappa gamma double dot. Therefore tau equal to, let us substitute for vector n here, so tau equal to minus n dot. So what is n? 1 by kappa times gamma double dot inner product with t cross n dot. So T is gamma dot. Okay. T is a gamma dot cross product with N dot. What is N dot? D by ds of 1 by kappa gamma double dot I will write d by dt because I am for the time being assuming that my curve is unit speed curve and the parameter is taken originally itself as t. Here parameterization with respect to t itself gives me a unit speed curve. That is my assumption in the first part of the proof, case 1. Okay, so that is equal to minus 1 by kappa gamma double dot inner product with gamma dot cross let us differentiate this with respect to t. So in the denominator kappa square, the numerator it is kappa into gamma triple dot minus kappa dot into d by dt of into gamma double dot. So this is the quotient formula. So what you will get? So here you have gamma dot, gamma double dot inner product with gamma dot cross, look at the second term, gamma double dot. So it is something like A dot B cross A, A dot B cross A. What is this? Here B cross A is a vector perpendicular to A. So A dot B cross A will be 0. So the second term vanishes after taking the dot product and the cross product. So you are only left with the first term. So minus 1 by kappa cube minus 1 by kappa cube gamma double dot inner product with gamma dot cross kappa times gamma triple dot. Okay, so that is equal to minus 1 by kappa square, because this kappa comes out and cancels with this kappa cube in the denominator and getting kappa square in the denominator into, now look at A dot B cross C. It is the same as B dot C cross A. It is the same as C dot A cross B. I hope you know that. But if you interchange this order, ABC order, and apply a permutation which interchanges only the 2 symbols instead of 3, then you will get a minus sign. So this is the same as this is my C, this is my A, B. So it is gamma triple dot inner product with, so C dot A cross B. I am going to write B cross A. So gamma dot cross gamma double dot. So I will get a minus sign in that case. That minus of minus is plus. So 1 by kappa square gamma triple dot inner product with gamma dot cross gamma double dot. Now observe that gamma is a unit speed curve. So gamma dot is perpendicular to gamma double dot. Since gamma is unit speed, gamma dot is perpendicular to gamma double dot. Therefore, you look at norm of gamma dot cross gamma double dot. Therefore, norm of gamma dot cross product with gamma double dot equal to norm of gamma dot into norm of gamma double dot into sine of the angle between them, its absolute value. So angle between them is pi by 2. So sine pi by 2 is 1, modulus is 1. So into 1. So this is equal to, now gamma is unit speed, norm of gamma dot is equal to 1. So this is simply norm of gamma double dot. But norm of gamma double dot is my curvature kappa. Therefore tau equal to, I will write here on the right side, and I will erase this part. Therefore tau is equal to kappa square. In the denominator is replaced by this norm of gamma dot in cross product with gamma double dot square. So gamma triple dot product with, inner product with gamma dot cross gamma double dot divided by norm of gamma dot cross gamma double dot square and this is the formula we wanted, right? Where is the proposition? Yes, this is the formula we wanted. So we have proved the result in case 1. Now we will go to case 2. So case 1 proved. Case 2. General case. In the general case, let us start with a gamma regular curve. We shall use the idea of case 1. So let S be the arc length. So if you parameterize with respect to arc length, you will get a unit speed curve, and you can find the derivatives using chain rule. So original parameter is t, regular curve with the original parameter t. Gamma is a regular curve with original parameter t. So let us look at d gamma by dt. D gamma by dt, it is d gamma by ds into ds by dt. This is by chain rule. Now let us look at d square gamma by dt square. That is equal to, it is by definition d by dt of d gamma by dt, and by chain rule this is d by ds of d gamma by dt into ds by dt. That is equal to d by ds of, what is d gamma by dt? This one. So d gamma by ds, ds by dt into this ds by dt. Now here you have to apply product rule. So you will get d square gamma by ds square into d by ds of into ds by dt plus d gamma by ds into d by ds of ds by dt. Into d by ds of ds by dt, okay, that into ds by dt, this ds by dt is this, okay. So that is equal to d square gamma by ds square into ds by dt the whole square. So I will write ds by dt the whole square first, and d square gamma by ds square plus, now look at the second term, d gamma by ds into d by ds of ds by dt into ds by dt. So by chain rule, this expression becomes, you can think of cancelling ds and ds. So this becomes d by dt of ds by dt, okay. You can think of this actually by chain rule. You can think of this ds and this ds cancel. So this is d by dt of ds by dt. What is d by dt of ds by dt? It is d square s by dt square, d square s by dt square into this d gamma by ds, d gamma by ds. Okay. Similarly, we find d cube gamma by dt cube, because our formula involves gamma dot, gamma double dot, and gamma triple dot. So here dot means differentiation with respect to the original parameter t. So d cube gamma divided by dt cube equal to, this is d by dt of d square gamma by dt square, which I am going to write as d by dt of, what is d square gamma by dt square, that is in the previous slide, yes, this expression in the right side. So ds by dt the whole square into d square gamma by ds square plus d square s by dt square into d gamma by ds. So ds by dt the whole square into d square gamma by ds square plus d square s by dt square into d gamma by ds. So this is equal to, now let us differentiate. So derivative of the first term plus derivative of the second term. Derivative of the first term is 2 times ds by dt into derivative of ds by dt is, with respect to t, is d square s by dt square into this term d square gamma by ds square, it is product rule, plus ds by dt the whole square into derivative of the second term with respect to t. So d by dt of d square gamma by ds square plus, okay, so let me do one thing here. Here itself I am going to apply chain rule. D by dt of d square gamma by ds square. This is a function of s. So I cannot write this as it is. So let us apply chain rule. So d by ds of then this into ds by dt. Okay, they are the same. So we have differentiated the first term plus. Now second term, d square s by dt square, its derivative with respect to t is d cube s divided by d cube dt cube into d gamma by ds plus d square s by dt square into d by dt of d gamma by ds. D by dt of d gamma by ds. But again, this expression as it stands is not useful. So because this is a function of s, so this is, I will write d by ds of d gamma by ds into ds by dt. Okay, understand? This is by chain rule. So this is equal to now how I am going to write this is let me write this term as the first term because it contains the third derivative. So d cube s by dt cube dt cube into d gamma by ds plus, now let us take a square d square s by dt square terms. So here there is one, and where else? Here there is one. So it is d square s by dt square into, this is d square gamma by ds square into ds by dt. And look at the first term, 2 times d square s by dt square into d square gamma by ds square into ds by dt. So the first term and the last term together will give me 3 times. 3 times d square s by dt square into ds by dt, that is there, ds by dt into what is remaining, d square gamma by ds square. Here it is there, here also it is there, d square gamma by ds square plus. So first term is this we have taken, this and this we have taken, and finally I am left with this. So what is this? This is ds by dt whole square into ds by dt. So ds by dt the whole cube, ds by dt the whole cube into, this is d cube gamma divided by ds cube. Fine? Yes. So I have found out this is my gamma triple dot, and in the previous slide this is my gamma double dot, and this is my gamma dot. Now what is our formula? Formula is this. So let us find out gamma dot cross gamma double dot. So gamma dot cross gamma double dot is equal to, what is gamma dot? Gamma dot is d gamma by ds by dt, or the other way around. This is scalar, this is vector. Usually we write scalar times vector, but for chain rule, saying this way is more convenient. So we often write in this way also. So ds by dt into d gamma by ds. So ds by dt into d gamma by ds cross product with gamma double dot. That is gamma double dot. It is here. It is ds by dt the whole square into ds by dt the whole square into d square gamma by ds square. ds by dt the whole square into d square gamma by ds square plus d square s by dt square into d gamma by ds. d square s by t square into d gamma by ds. You'll get this. So look at first term versus the cross product with the third term. So you have something like a cross a. What is a cross a? It is equal to 0. So this is the 0 vector. So you are left with this scalar can be taken out. So ds by dt into ds by dt the whole square, it is ds by dt the whole cube into d gamma by ds cross d square gamma by ds square fine. Now let us compute norm of gamma dot cross gamma double dot norm square. So what is this? Norm square I have to take. So it is ds by dt whole to the power 6, its modulus. But since this is 6th power, which is always non-negative, times norm of d gamma by ds cross d square gamma by ds square, square of that. Okay. Now let us use case 1. From case 1, tau is given by, if gamma is a unit speed curve, then tau is given by the formula what? This formula. So I have to write d cube gamma divided by ds cube dot product with d cube gamma divided by ds cube dot product with d gamma by ds cross d square gamma by ds square divided by norm of d gamma by ds cross d square gamma by ds square, square of that. Okay. This is equal to what I do here is multiply and divide throughout by ds by dt whole to the power 6. So I will do here itself. So let me erase this part. So I will multiply and divide throughout by ds by dt whole to the power 6. So ds by dt whole to the power 6. Here also ds by dt whole to the power 6, and this is my tau. And what is this object? And what is the denominator? Denominator is precisely norm of gamma dot cross gamma double dot square. Denominator is precisely norm of gamma dot cross gamma double dot square. And what is the numerator? We have to see. Yes. D cube gamma divided by ds cube into what is the numerator? Okay, we forgot to do one computation, so that we will do in the next slide. What is the formula? Formula is gamma triple dot product with gamma dot cross gamma double dot. So let us compute gamma triple dot with gamma triple dot product with gamma dot cross gamma double dot, which is equal to gamma triple dot. What is that? Gamma double dot. This is gamma triple dot, right? Gamma triple dot is this expression. D gamma by ds is there. D square gamma by ds square. D cube gamma by ds cube with some appropriate scalars. Dot product with. Okay, so let us write something into d gamma by ds plus something into d square gamma by ds square plus something into d cube gamma by ds cube, that is gamma triple dot product with gamma dot cross gamma double dot, that we have already found out. Yes, some scalar into d gamma by ds cross d square gamma by ds square. Some scalar into d gamma by ds cross d square gamma by ds square, right? So what I will get? So d gamma by ds dot product with d gamma by ds cross d square gamma by ds square. So a dot a cross b, which is equal to 0. Similarly, d square gamma by ds square dot product with d gamma by ds cross d square gamma by ds square. Again, it is something like a dot b cross a, which is equal to 0. So you are left with only this much. So this scalar into this scalar into d cube gamma by d s cube dot product with d gamma by ds cross product with d square gamma by ds square. So what are those scalars? We have to pick them up. So I think this is that scalar ds by dt whole cube. This is one scalar. ds by dt the whole cube into what is this scalar? From where this scalar is coming? It is from the computation of gamma dot cross gamma double dot. So what is that scalar? It is again, yes, ds by dt the whole cube. ds by dt the whole cube into this expression as it is. d cube gamma by ds cube dot product with d gamma by ds cross d square gamma by ds square. So this is again ds by dt whole to the power 6 into this expression in the square brackets. Okay. So now let us go back to the previous computation, tau, and in the numerator you have to substitute for this expression. What is this expression? That is what we have just found out. ds by dt whole to the power 6 into d cube gamma divided by ds cube dot product with d gamma by ds cross d square gamma by ds square. This expression. So what is this? This is precisely what we have computed. Gamma triple dot dot product with gamma dot cross gamma double dot. So let us substitute there. So this is gamma triple dot inner product with gamma dot cross gamma double dot. And I think this is the formula we wanted to prove. Yes, this is the formula we wanted to prove, and we proved the formula in the general case as well. Thank you.